Okay, next slide ke next slide ke the end and slide shifting etlaga idena next slide కావాలంటే ఇక్కడ నొక్కగా ఇక్కడ ఇవి అప్ అండ్ డౌన్ చేస్తుంటే సరిపోతుంది కదా సరే పర్లేదు sorry, there was some technical problem. Anyway, whatever you could hear before this, that's one. And let's see how the anatomy and the physiology of every structure has to be known before we understand the various diseases. It may be in the form of inflammatory, traumatic, neoplastic, or otherwise various other conditions, the congenital conditions. So we should basically understand what is normal anatomy and what is normal physiology, and how these changes that are brought about by the inflammatory, traumatic, and neoplastic conditions or the congenital conditions, how they alter the anatomy and also bring about the changes in the physiology of structure, and produce what are known as various diseases or the disorders. So we should understand this. So in the ear, I'll just briefly tell you about the anatomy. The external ear, which consists of the pinna and the external artery meatus, and that ends at the tympanic membrane. And after the tympanic membrane, it is the middle ear, which extends from the tympanic membrane to the inner ear, bony part of the inner ear. So that space is called the middle ear cavity. And this middle ear cavity is connected to the nasopharynx by a small tube called the eustachian tube, which the function of which is to equalize the pressure, air pressure between the middle ear cavity and the outside atmosphere. Okay, so that's a delicate function which is done by the eustachian tube. Then you have the inner ear, which consists of the cochlea, which is responsible for the hearing mechanism, and the vestibule and the semicircular canals are the ones which are responsible for the balancing mechanism. So that is in brief about the structure of the ear. Now, if you come into the physiology part of it, in the physiology, sound waves travel from one place to other in the form of waves in the medium. It may be air medium, it may be the water medium, or a liquid medium, or a solid medium. So the air travels in the external air, vibrations travel in the external auditory canal, because external auditory canal is filled with air, and the major content of the middle ear cavity is also air, whereas the inner ear is the one which consists of fluids. Okay, so let's see how the mechanism of hearing works, the physiology of hearing. And in this, the vibrations travel in the air, and the same vibrations are transmitted onto the tympanic membrane, which in turn um, transmit these vibrations to the three ossicles, malleus, incus, and stapes. Malleus, incus, and stapes, the three bones. Stapes is the one which has the footplate of the stapes is the one which covers the oval window, and beyond the oval window, you have a chamber called scala vestibuli. And the inner ear has got three chambers: the scala vestibuli, scala media, and scala tympani. So the vibrations from the external auditory canal transmit via the ossicles in the middle ear cavity to the inner ear fluids. And in these fluids, as I said, there are three chambers which are separated by two membranes. One is the Reisner's membrane, and the other one is the tectorial membrane. So the uh, tectorial membrane, on which the organ of Corti is there, with its sensory hair cells, which receive the vibrations which are transmitted from the air to the fluid, the scala vestibuli, scala tympani, and the scala media. And these vibrations in turn vibrate the tectorial membrane, and the sensory hair cells are the ones which get stimulated. The sensory hair cells are the ones which get stimulated, and there is a small electrical potential that is created, the plus and the minus. So the there is an exchange of the ions, and then the electrically they become active, and these electrical waves are the ones which travel in the nerve in the form of a wave of depolarization. So basically, if you see the mechanical vibrations of the that are present in the air that are transmitted onto the tympanic membrane, the ossicles, from there into the inner ear fluids, where the membranes vibrate and stimulate the nerve cells, the inner hair cells, and the hair cells are the ones uh, which convert this mechanical energy into electrical impulses. This process is called the transduction. Transduction is a process wherein the mechanical energy is converted into the electrical potential, and so the ultimately the waves uh, uh, are converted into electrical potential, and through these electrical potentials are the ones which are carried by the nerves to the central nervous system, and you have the perception of the hearing to the auditory cortex. So that is briefly the mechanism of the ear, the function. At the same time, the semicircular canals, the fluids which are present in the semicircular canals, and there are small dilated ends which are called the ampulla, where you have the sensory hair cells. The fluids in the semicircular canals move, and they are the ones which stimulate the cells that are present in the ampulla, and there once again the mechanical energy is converted into electrical impulses, and the vestibular um, sensations are carried through the vestibular nerve. So this is briefly about the anatomy and the physiology. And if you see, supposing there is wax in the external auditory canal, and the vibrations which are traveling up to that cannot go and onto the eardrum because of the blockage there, or some kind of inflammatory process, or some kind of a new growth there, which will occlude the external auditory canal, then the hearing mechanism comes down. The hearing comes down because the air column that is traveling in the external auditory canal is blocked by this external, whatever is the structure. So, and supposing there is a perforation in the eardrum, the vibrations, the perforation, because of the amount of vibrating structure of the tympanic membrane is reduced, and so there is a hearing loss. Or if there is an injury or inflammatory process where uh, the ossicles are destroyed and there is a discontinuity of the ossicles, the vibrations that vibrate the tympanic membrane cannot transmit them into the inner ear because there is a ossicular discontinuity. And once they go into the inner ear, the hearing, the air cells that are present are the ones which convert the mechanical energy into the electrical potential. And so if there is a problem in the, or a decrease or absence of these inner hair cells, then also the hearing gets affected, which is called the sensory neural hearing loss. So these are the various disorders. Or supposing there is some kind of a fluid in the medullary cavity in the form of purulent, the pus, the discharge, in the purulent material in the medullary cavity in the conditions like acute otitis media, then they definitely impede the movement of the tympanic membrane, and so the vibration, the hearing becomes less. So this is how we can study the various at various levels how the anatomy is altered, and thereby there is a decrease in the performance, and that is the physiology of the hearing comes down, and which can be corrected depending on the whatever is the cause. So this is how briefly we should try to evaluate, and there are so many investigative procedures which have come in handy so that we can assess where exactly is the problem and how much is the problem. These are nothing but the audiometers, and of course in the bone, uh, the infective material, maybe you have some kind of a tuning forks test which can detect the conductive deafness. And sometimes if there is a disease process or a tumor, then the scans, CT scans, will tell us where exactly is the problem. And so by identifying the problem, we'll be able to look for a solution. We can take out the whatever is the cause and give back the normal physiology of the hearing. So this is how we should go about. And the next is the otology, is something to do with the ears, and rhinology is the one which gives us the knowledge of the nose and the paranasal sinuses. Nose, as you know, starts from the anterior nares, and that is the beginning of the respiratory tract. And as from the anterior nares, the air passes through the nasal cavity, it goes into the nasopharynx, then it goes into the oropharynx, laryngopharynx, and then it goes through the larynx into the trachea. The trachea, how it divides into the bronchi, and these bronchi in turn, how they the various bronchopulmonary segments and how the uh, pulm bronchopulmonary segments and segmental bronchi, and they in turn divide further into smaller bronchioles and ultimately the alveoli. So the respiratory system starts from the anterior nares and ultimately ends in the alveoli. So we need to understand what is the function of this nose. You can also breathe through the mouth, because if you breathe through the mouth, the air goes through the oral cavity and then it goes into the oropharynx, laryngopharynx, and the larynx, and thereby it goes into the lungs. So you have the other passage also, but what is the uh, and what is the function that the nasal cavity does? Mainly, the functions of the nasal cavity and the paranasal sinuses are described as, firstly, they are the passages of air coming in and going out. Okay, that is which is called inspiration and the expiration. Secondly, they are the ones which humidify as the air is passing through the nasal cavity. It humidifies the air that is passing through, so that the air that is going into the lungs is humidified, which is most essential for the normal functioning of the lower respiratory tract. Then you have the temperature control. When the cold air is inhaled, it within a small span of time before it passes through the nasal cavity, it almost comes to the normal temperature of the body, and this is facilitated by the rich blood supply in the nasal cavity and the small projections that are there in the lateral wall of the nasal cavity, which are called the turbinates, the inferior, middle, and superior turbinates. And these are the ones which are very vascular, particularly the inferior turbinate. And as the blood is warm, the air which comes in contact with the blood or submucosal, that the blood vessels, the air gets heated up. So the temperature regulation, the humidifying of the air, and of course the filtration. The filtration of the nasal cavity is one of the functions, wherein anteriorly you have in the vestibule, in the first part of the nasal cavity, the vestibule, where you have the fine hairs, which to some extent grossly stop the uh, bigger particulate matter. And as the air passes through the nasal cavity, you have the nasal cavity. Major part of the nasal cavity is lined by an epithelium which is called the respiratory epithelium, which is otherwise called the respiratory epithelium, which is otherwise the pseudostratified ciliated columnar epithelium, which lines the entire major part of the nasal cavity and also the lungs. So the function of these is to produce mucus, and as the air is passing through the small particulate um, matter get adherent to the mucus, and there is a mechanism which is called mucociliary clearance. Mucociliary clearance, wherein the cilia which are present in the nasal cavity and also the lower respiratory tract are the ones which move the mucus in the nasal cavity. They move the mucus from front backwards, and so there is a movement of the mucus which is from the nasal cavity to the nasopharynx. From there it goes into the oropharynx and then the laryngopharynx, and then you swallow. So the small dust particles which are attached to the mucus are the ones which go into the stomach. They are prevented from going into the larynx and then into the trachea and the bronchi and the alveoli. So this is how the nasal cavity protects, apart from the function of smelling, sensation of smell. These are the other functions: the humidification, temperature regulation, and the filtration. These are the functions primarily done by the nasal cavity. And if somebody is breathing through the mouth, then there is no filtration, there is no humidification, there is no temperature regulation, and so the dust particles the directly go into the respiratory tract and then produce repeated chest infections. For example, in conditions where there is the adenoiditis, which is quite a common condition in the children, the nose is blocked, and so the children start breathing through the mouth, and so there is no filtration, there is no humidifying by the mucus, and so the temperature is also not regulated, and so the air, unfiltered air, goes into the lungs and then produce repeated respiratory tract infections. So the main function of the nasal cavity is to protect the lower respiratory tract. And then apart from that, you have the sinuses, which are called the paranasal sinuses. These sinuses are the ones which are usually divided into two groups, the anterior and posterior groups. The anterior one is the frontal sinuses, the ethmoidal sinuses, anterior ethmoidal sinuses, and then you have the maxillary sinuses. These are the sinuses which commonly open into a space called the middle meatus. Then you have the middle ethmoidal, which are draining into the middle meatus again by a separate opening, and the superior or the posterior ethmoidals are the ones which open into the superior meatus, and the sphenoid is the other one. The sphenoid sinus is the one which drains into the sphenoethmoidal recess. So this is how the sinuses, the paranasal sinuses, all of them have connection into the nasal cavity. They drain by small uh, passages into the nasal cavity. And so whenever there is an obstruction to these passages, there is accumulation of mucus which get infected and give rise to the conditions called the sinusitis. So, and the function of these sinuses, usually they contain air normally, and so they act as resonating chambers in the production of the voice, the phonation. And then we go to the um, so that is about the nose. So we have covered the ear and nose and paranasal sinuses. Then the throat. Of course, the throat, the oral cavity, and the pharynx, oropharynx, and you have these the hard palate, the soft palate which form the roof, and the floor by the floor of the mouth. The tongue is the organ which is present, and then you have the laterally the cheeks, the vestibules, and anteriorly, of course, the from the starts from the lips, the oral cavity, and the oropharynx is a demarcation between the oral cavity and the oropharynx, wherein the anterior pillars, that is the palatoglossus muscle, which is coming from the palate to the tongue and attached to the tongue is divided into anterior two-thirds and the posterior one-third. And so at the junction, the palatoglossus muscle is attached. And so From there, behind it is the oropharynx, and the oropharynx consists of the tonsils, the base of the tongue, the vallicula, and the posterior pharyngeal, um, the oropharynx, the posterior pharyngeal wall, and of course the laterally you have the tonsils. So this is what the oropharynx is, and then we go to the oropharynx leads into laryngopharynx, and this laryngopharynx leads into the larynx, and then the larynx further continues down into the trachea and the bronchi and the segmental bronchi and the alveoli, bronchioles and alveoli. Okay, so the larynx is the one which is the gateway, which is the gateway of the entry into the lower respiratory tract, air going into that. Uh, so the function of the larynx, it has got the main function of the larynx is the protection of the lower airway. It doesn't allow the saliva or the liquids when you drink liquids or any foreign bodies trying to go into the larynx, into the lower respiratory tract. The main function is to protect the lower respiratory tract, and this is done by various mechanisms, various levels of valves that are used. One is the airy epiglottic folds, which form the first level of defense, where when they come together, the aperture is closed, the laryngeal inlet is closed. Then you have the false vocal cords. The false vocal cords are the ones which um, uh, which can come together and block the passage during the deglutition. And the third one is the true vocal cords. The true vocal cords have very powerful adductors, and so these three levels are the ones which become active when the saliva or the air or the food tries to go into the larynx, and the so that is the main function. Apart from this, there are other functions like the phonation. The basic voice is produced in the